So in case of balancing chemical equation, there are some guidelines which we have to go through. So first thing is, never change the subscript of molecule or compound when balancing, and changing the subscript will change the identity of the molecule or compound. We have seen example for water, H2O2, H2O, and if we are going to add one subscript in at the end of oxygen, H2O2, so this subscript after oxygen will change the whole chemical formula. So this is water, H2O, and this is H2O2 is hydrogen peroxide. So in balancing reaction, we never use any subscript, we always use coefficient in front of the molecule, not at the end of this any atom. So this is not correct. Next is, start with the element which appear the least amount of times in a reaction, often the metals. This is the second rule. Third is, if an element is in the reaction, balance that element last. So element means like hydrogen or oxygen gas or chlorine gas or iodine gas. These are diatomic molecules, or elements will be also some metals. If only compounds are in the reaction, balance the hydrogen atom and oxygen atom last, because they appear in many compounds. So we'll see one example for methane gas. Burning of methane gas in oxygen. So you can see this is an unbalanced equation, because there are one carbon on this side, which is good, one carbon in the product side, 4 hydrogen, but here is only 2 hydrogen. Oxygen is 2, but there oxygen is total 3, 2 and 1. So balance. So we have to see here one carbon, and then hydrogen is 4, and then oxygen is 2 oxygen atom. On this side one carbon is there, 2 hydrogens are there, and 3 oxygens are there. So in the least amount is carbon is in the least amount. According to rule, we will balance this first, and then we will balance hydrogen at the end. So balance first carbon is because it is in the least amount, and balance hydrogen in the second, and then oxygen. So what we have to do, since we have to balance carbon first, so carbon is already balanced because one carbon is on this side and one carbon is on that side. Only we have to balance in this chemical equation hydrogen and oxygen. So we'll add one coefficient in front of oxygen and this water molecule. So now you can see there are total 2 by 2, 4 hydrogen and 4 hydrogen on this side. So hydrogens are now balanced, carbon is already balanced. Now we have to count how many oxygens are there. So this 2H2O means there are two water molecule, H2O and H2O. So there are 2 oxygen on this side and 2 oxygen on this. So total 4 oxygen. But here is only 2 oxygen. So now we have to balance oxygen by adding one more coefficient in front of oxygen molecule, 2. So this means there are 2 oxygen molecule like that. So there will be total 4 oxygen. So now everything is balanced. So this is the balance equation. So similar way we have to see some more examples. Here is to balance sodium carbonate plus HCl, sodium chloride, water and carbon dioxide gas. Aluminum, when they act with oxygen it form aluminum oxide. Ferric carbonate, when they act with sulfuric acid it form ferric sulfate and water and carbon dioxide gas. Tetra phosphorus deca oxide, when they act with water it form phosphoric acid. Ethanol, when burned in oxygen it form carbon dioxide gas and water molecule. So we'll see one by one how to balance each equation. So in this equation first we have to calculate sodium carbonate plus HCl, sodium chloride plus water and carbon dioxide gas. So we have to count how many sodiums are there. There are 2 sodium, 1 carbon, 1 carbon and 1 HCl, 1 chlorine, 1 carbon and 1 chlorine and 1 hydrogen, and oxygens are 3. On this side 1 sodium, 1 carbon, 1 chlorine atom, 2 hydrogen atom and 3 oxygen atom, 2 from carbon dioxide gas and 1 is from oxygen water molecule. So what we have to balance first, carbon is in the least, chlorine is in the least, we balance hydrogen and oxygen at the end. So probably we have to balance chlorine and first. So we added 1 coefficient in front of NaCl which is 2. So now chlorine will be balanced, 2 chlorine on this side, 2 sodium on this side, this sodium will be here, there are 2 sodium and here is only 1 sodium. So now the sodium will be balanced, and then but there are 2 chlorine will be there because we added 1 coefficient here. So coefficient means there will be 2 sodium chloride molecule. So we have to add 1 more coefficient on this side, number 2, so that we can balance chlorine. So 2 HCl. Now when you will calculate, so everything look like everything is balanced automatically. So 2 sodium on this side, 2 sodium on this side, carbon 1, carbon 1, hydrogen 2 on this side by adding this coefficient 2 of HCl, and then 2 hydrogen from water molecule, oxygen 3 from carbonate, and oxygen 3, 1 from water molecule, 2 from. So this was already balanced. So everything is balanced now. So we added only 2 coefficient in front of NaCl and 2 in front of HCl. So second example is for aluminum chloride to make alumina. So again once we have to find out 1 aluminum on this side, 2 aluminum on this side. So we have to balance aluminum first. It's very easy, just add 1 coefficient in front of aluminum, 2, and then 2 and 2 of both will be balanced. Now we have to balance the oxygen. On this side is 2 and this side is 3. So it's very simple, you can just cross multiply to each other and then will be balanced. So we can add 3 coefficient in front of oxygen. So this will become total 3 multiplied by 2, 6 oxygen, and here also we added 2 coefficient in front of aluminum chloride, so this will become total 2 multiplied by 3, 6 oxygen on this side also. But now you can see aluminum will become 4. 2 multiplied by 2. So what we have to do? We have to change this coefficient from 2 to 4. So now this is the balance equation for aluminum when react with oxygen to form alumina. 4 aluminum atom will react with 3 oxygen molecule to form 2 aluminum oxide. So this was the second example to balance the chemical equation. Let's see the third one, which was iron carbonate and sulfuric acid. Let's zoom a little bit more so that you can see better. So here when we will count, so 2 iron and this carbonate is have 1 parenthesis and there is 3. You can see like this here. So parenthesis 3 means you have to multiply everything by 3. So there will be 3 carbon and 3 multiplied by 3 will be 9 oxygen. 9 oxygen. And then here are 2 hydrogen, 1 sulfur, oxygen, 1 sulfur and 4 oxygen. On this side 2 irons, and then sulfate have 3 parentheses, so everything will be 3. So 3 sulfur and oxygen will be 4 multiplied by 3, so 12 oxygen. And then 1 here, 13, 14, 15, total 15 oxygens are there. 1 carbon and hydrogens are 2. So now you can see, to balance this equation what to do. First we will add, so 1 carbon on this side and 3 carbon on this side. We will add 3 coefficient in front of carbon dioxide gas so that we can balance the carbon first. They are here in the least amount. So once you will add 3 carbon, and then on this side you can see 3 sulfur and only 1 sulfur, sorry, 1 sulfur is here and 3 sulfur are here. So we will add one more coefficient in front of sulfuric acid, 3, to make sulfur 3. So now we can count. So 3 carbon this side, 3 carbon this side, iron 2 is this side, iron 2 is this side, and then sulfur 3, sulfur 3. Now only remain is hydrogen and oxygen balancing. So total hydrogen on this side will be 3 multiplied by 2, 6, and total hydrogen on this side will be 2. So we need to add big number here somewhere. So we can add 3 in front of water molecule. So 3 multiplied by 2 will be 6 hydrogen. 6 hydrogen this side and 6 hydrogen this side. So what hydrogen is also balanced. Now what is remain? Oxygen. So now we can calculate total number of oxygen will be 4 multiplied by 3, 12 oxygen in the sulfuric acid, because this has a coefficient subscript number 4, and then you have to multiply it by coefficient to find out total number of oxygen is 12, and here you have to multiply this subscript by 3 to 3, total 9. So 9 and 12, 21 oxygen on this side. Now we have to balance oxygen on this side. So 4 multiplied by 3, 12, and then 3 from the water molecule, 15, and then 3 multiplied by 2, 6 from here. So 15 plus 6, this is also 21 oxygen. So now everything is balanced. So this would be a balance equation for ferric carbonate when react with sulfuric acid to form ferric carbonate and water molecule and carbon dioxide gas. So this was the 3 example to understand how to balance any chemical equation. Let's see 2 more. So now we will see example number 4, how to balance this reaction. So first we have to count how many phosphorus are there. So 4 phosphorus, 10 oxygen, 2 hydrogen and 1 oxygen on the reactant side. On the product side there are 3 hydrogen, 1 phosphorus and 4 oxygen. So first we will balance phosphorus. So because this is in the least amount, and we balance what hydrogen and oxygen at the end. So what we have to do, we will add 1 coefficient in front of phosphoric acid, number 4, then phosphorus will be balanced, 4 phosphorus on this side reactant side and 4 phosphorus on product side. Next, so total, now you can see total hydrogen will be, after adding this coefficient 4, so multiply this subscript, so 3 multiplied by 4 is equal to 12 hydrogen, and on this side there will be only 2 hydrogen. So what to do? Now we have to balance the hydrogen. So we can add some number here, some coefficient which can balance 2 to 12. So basically you have to just multiply it by 6, then everything will be balanced. So when you will add 6 in front of water molecule, so 6 multiplied by 2, 12 hydrogen, and 4 multiplied by 3, 12 hydrogen, and 4 phosphorus, and then let's see, and 4 phosphorus are also here. Now we have to count how many oxygen atoms are there. So 10 from this molecule plus 6 from the water molecule, total 16. Total 16 oxygen on this side. Let's see how many will be there here. So 4 coefficient means 4 molecules of phosphoric acid, and each molecule of phosphoric acid has 4 oxygen atom. So 4 multiplied by 4, 16. So oxygen is also balanced. So to balance this reaction, what we did, we added 4 in front of phosphoric acid and 6 in front of water molecule, and that's it. This reaction is balanced now. Let's see one more example. Fifth example is C2H5OH, which is ethanol. When burned in presence of oxygen, it produces 1 mole of carbon dioxide gas and 1 molecule of water molecule. So let's see how many elements are on both sides. So 2 hydrogen and then oxygen are 5 and 1 6 hydrogen, and oxygen is 1 and 2 from O2, so total 3 oxygen. Here 1 carbon, 2 hydrogen, and 2 and 1 3 oxygen. So oxygens are equal but hydrogens are unbalanced and carbons are unbalanced. To balance 2 carbon, we can add 1 coefficient in front of carbon dioxide, number 2, then it should be balanced. So we add one coefficient 2 in front of carbon dioxide gas, and now carbon will be balanced. So now you can see 6 hydrogens are still there. So carbon 2 is balanced, carbon 2 is balanced. 6 hydrogen on this side, and oxygen are 2 and 1 3 oxygen. But here what happened, 2 multiplied by 2 4 oxygen and 1 oxygen from water molecule, total 5. So 3 and 5. So how to balance? So we have to add one more coefficient, basically first to add balance the hydrogen. So this is general rule kind of, that you have to balance the minimum amount of carbon or other element first, and then hydrogen, and then oxygen at the end. So 6 hydrogens are here and 2 are here, so we added one coefficient number 3 here. So 3 multiplied by 2, 6 hydrogen, hydrogens are balanced already, carbon we have already balanced, and now oxygen. So 1 oxygen here and 2 are here, total 3, and 2 multiplied by 2 4, and here 3 7. So we have to add something else. So we have to add, so you can see total oxygen are here 3 plus 4, total 7, 4 plus 3 7, but here only 3. So we added one coefficient 3 in front of oxygen. So now there will be total 6 oxygen, and 1 is from here, total 7, and this is already 7. So this will be equation will be balanced. So these were the 5 examples to balance the chemical reactions we have studied, and you can learn some more from other examples to how to balance the chemical reactions, and we will see other in other slides.